Hello everyone. In this lesson we explain how to properly interface and use the camera in ROS2 Jazzy Jalisco. And on the screen you can see a small demonstration that you will learn how to implement in this video tutorial. Over here you can see the communication graph and ROS2 nodes. Namely, we have a publisher node that uses OpenCV to take a set, or better to say a stream of images, and you can see the images over here that are actually published on the screen, or better to say displayed on the screen by using the subscriber node. To summarize, the publisher node uses OpenCV to take the images, then it converts images to an appropriate ROS2 form and communicates the images through this topic called topic camera image. On the other side, we have a subscriber node that receives the images, then it converts them back into the form that can be displayed on the screen, and it displays the images on the screen. And you can see how in real time the images are being acquired, communicated, and displayed. Over here in this terminal, you can see the publisher node that's running. Then over here you can see the subscriber node that's running, and over here in this node we are running this graph and showing this graph. Okay, let's start with explanations. First of all, you have to make sure that you have the correct versions of ROS2 and Ubuntu installed on your system. Otherwise, the implementation presented in this tutorial might not work. This tutorial is based on ROS2 Jazzy Jalisco distribution and Ubuntu 24.04. Later on in this tutorial, we will explain how to check if you have the correct ROS2 and Ubuntu distributions. Now, here is the copyright notice. This document and the lesson video should not be copied, redistributed, or publicly posted on public or private websites or social media platforms. The code files are for the personal use and they should not be posted publicly and or on personal code repositories. The code should not be used for commercial purposes without paying an appropriate fee to the author. It should also not be used as lecture material on online learning platforms and in university courses. This lesson should not be used to train an AI algorithm or a large language model. Okay, this tutorial will work for any type of a camera, such as for example a web camera. The only condition is that the camera can be recognized by the Linux system. In this tutorial, we will explain all the steps you need to perform in order to establish a ROS2 camera OpenCV interface. You need to carefully read this tutorial and watch the video in order to be able to successfully implement the camera interface. That is, this tutorial is not for impatient and easy to distract students or engineers. You need to carefully follow and try to understand every step performed in this tutorial. Only like that you will be able to learn ROS2. Okay, so let's start with the first step, or with the zero step, better to say. We need to verify that we have the correct Linux and ROS2 distributions. Okay, for that purpose I'm going to resize this window and I'm going to open my terminal by clicking here and by searching for terminal. Here it is. To verify our Linux distribution, we simply need to write this command over here. And if you see Ubuntu 24.04, this is good. You can continue watching this tutorial. Otherwise, you need to install Ubuntu 24.04. Next, let's verify that you have the proper version of ROS2 Jazzy Jalisco. To do that, try to source this file. And if you don't see any error, this is good. However, the best check is actually to print this environment variable called ROS_distro. So let's do that, and if you see Jazzy, this is good. You actually have Jazzy Jalisco installed in your system. All the ROS distributions on your system are actually in this folder. So if you type cd opt ROS and if you type lsla, you should see Jazzy. All the ROS2 Jazzy Jalisco files That is, all the installation files are placed over here. In the next step, we need to verify that we can take camera images, and we need to verify the camera device number. To do that, first of all, you need to attach your USB camera to the computer. In the previous versions of Linux Ubuntu, there was a built-in application called Cheese for taking images and recording videos. However, in Ubuntu 24.04, this version is not built into the Linux Ubuntu system. We notice that a default program coming with Ubuntu 24.04 called Snapshot might not be working, and consequently we will need to install some other program for verifying that we can actually capture images and that the camera is working. Just to show you for a second, click here and search for either camera or Snapshot, and you will see this program. And I'm not going to run this program since it's not working for some reason on my system. You might try to run this program and to verify if the camera is working. However, this program is not working on my system, and not only on my system, it's also reported online that there are a number of users who are having problems with this built-in program. Consequently, let's install an alternative program. The name of this program is Camoo. So let's install that program. First of all, run this, update, enter your password. Then over here, type sudo apt install snapd. And finally, we can install Camoo by simply typing sudo snap install Camoo. So let's be patient over here, since this might take some time. Again, you can also try some other program. Okay, so let's start Camoo and let's verify that we can take images. So click here and search for Camoo. And here it is. Click here and then let's wait and see if we are able to take images. And you can see that my camera is working and it can take images. Perfect. Notice over here that the frame rate is relatively slow. However, the frame rate in our ROS2 program will be much faster. So let's close this program, and this is very important. Don't forget to close Camoo. So close Camoo, otherwise we will not be able to use the camera later on. The next step is to verify that our command line can see the camera, and we need to verify the camera number. To do that, you need to type this. And in my case, the camera is actually 0. That is, this device video 0 is my camera. It's very important to remember this number since we will need to enter this number in our Python code. That is, the device number of my camera is 0. In your case, you might see 1 or 2 or 2 or 3 or something similar, and then you will need to do checks, right? You will start with, for example, 1 and check if the code is working, and then if it's not working, try another number, etc. However, you will either see video 0 or video 1, or you might see video 1 or video 2. Next, we need to verify that OpenCV and other necessary packages are installed. First of all, in the terminal, type this. This will show the current version of OpenCV. In my case, it's 4.6.0. However, if you don't see the current version of OpenCV, you can install OpenCV like this. OpenCV should come with the ROS distribution, and however, in some cases, you might not see OpenCV, and to install it, you can simply install it like this. Okay. Next, we need to verify that several packages are properly installed. We need to verify the following ROS2 packages. RCLPY, this is the ROS2 client library for the Python language. Then we need to verify that we have image transport. This package is used to subscribe to and publish images. Then we need to verify that we have CV Bridge. This package is used to convert between ROS2 image messages and OpenCV image representation. Then we need to verify that we have sensor messages. Sensor messages is a package that is used for messages and services related to sensor devices, and we need to verify that we have standard messages. This package is used to send and receive standard messages in ROS2. So how to verify that a certain package is installed? Well, first of all, you need to source your ROS2 distribution by running this, and then you can simply verify if a certain package exists on your system by typing ROS2 package prefix, and you can simply type over here the name of the package. So for example, if I want to verify that RCLPY is installed, I will run this and I should see the output path of my RCLPY installation folder. That is, if I see something right now as the output, this means that RCLPY is installed in this folder. Okay, so let's do this for all the packages. Image transport, make sure, okay, let's do CV bridge. Perfect. Let's see sensor messages. Okay, and let's see the standard messages. Okay, we have all these necessary packages. Next, let's make sure that we have an editor such that we can edit Python files. In this tutorial, I'm going to use gedit since it's very convenient and easy to use. So to install gedit, simply type sudo apt-get install gedit. And as you can see already over here, gedit is installed in my system. However, in your case, you will see the installation progress. The next step is to create a workspace and a package. So let's close this terminal and let's start a new terminal such that we can practice sourcing the environment and creating packages. Okay, so we're starting here from scratch. Let me just resize this window for a second. And whenever you want to do something in ROS, you need to source this setup.bash file. So let's do that. Okay, then make sure that you're in the home folder by typing this. And we need to create two folders. The first folder will be our workspace folder, and inside of that folder we are going to create the source folder. We can create these folders by executing this command. This command will create a folder called ws-ros2 camera, and inside of that folder it will create also the source folder. Good. Then let's go to our base or the workspace folder by typing this, and let's execute colcon build. This will initialize the build and empty workspace and package. Okay, next let's navigate to our source folder by typing this, and keep in mind that all the files will be placed in the source folder. That is, our source package files will be placed over here. We want to create an empty package, and inside of this package we want to add several things. To create a package, we need to execute this line. ROS2 package create, then we need to specify the build type. It's going to be mn python. Then we need to specify the name of the package. This is very important. My name will be ROS2 underscore OpenCV, and we need to specify the dependencies. Our package will depend on sensor messages, standard messages, RCLPY, image transport, CV bridge, and Python 3 OpenCV packages. Okay, so let's execute this command. Here it is. Now you can inspect the structure of this folder. You will see already that inside of this folder a new folder is created, and inside of this folder we will place our source files. The next step is to create the publisher and subscriber nodes. Let's start with the creation of the publisher node. First, we need to navigate to the main package folder where the source files will be placed. Consequently, we need to go to this folder. And let's create the publisher node file. To do that, simply type gedit camera publisher.py, and over here, to save time, I will simply copy and paste the content of my publisher file, and I'm going to explain this file line by line. First of all, we need to import the necessary libraries. We need to import OpenCV. We import OpenCV as CV2. Next, we need to import the ROS2 package, modules, and libraries. We need to import RCLPY, then from sensor messages, we need to import images, since we will be reading images and sending images. Then from RCLPY.node, we need to import node, since we will be creating a node. Then from CVBridge, we need to import CVBridge. Okay. Then we need to define a class that will implement our publisher node. I will call this class as publisher node class, and note over here that we have a node written. So what is this node? This means that the publisher node class inherits or is a child of the standard ROS2 class called node. And we need to do several things over here. Here is our constructor. This function is used to initialize the attributes of the parent class. We call our node the publisher node. Over here, we create an instance of the OpenCV video capture object such that we can take or capture frames from our camera. And over here we need to specify the camera device number. Do remember that at the beginning of this video tutorial we retrieved the camera number, and you need to specify or enter the correct camera number. In my case, the camera was device 0, consequently I will place 0 over here. In your case, if the camera has some other number, you need to populate this number. Then you need to write self.camera is CV2 video capture self camera device number to initialize the camera. Then we need to use CVBridge. CVBridge is used to convert OpenCV images to ROS2 messages that can be sent through the topics. Consequently, you need to type self.bridge object CVBridge. Next, we need to create a topic and give a name to that topic that will be used to transfer the camera images. In my case, the topic name will be topic camera images. Then we need to specify the queue size for messages. The queue size is 20. This is a buffer. Then the function self.createPublisher creates the publisher that publishes the messages of the type image over the topic self topic name frames and with self queue size. So to create the publisher, we will specify image as a data type. Then we will need to specify topic name frames and the queue size. Then we need to specify the communication period in seconds. Over here the communication is 0.02 seconds. Then we need to create a timer that calls the function self.timer callback every self.period communication seconds. And here is the timer. We create the timer, we specify the input parameters, here they are. And this is the counter over here for tracking how many images are published. We simply initialize this counter with 0. Then, here is our callback function. This callback function is called every self.period communication seconds. That is every 0.02 seconds. And this callback function will do all the work. So what do we do over here? We read the frame from our camera, then we resize the image as 820 by 640, and we use interpolation intercubic. This is a standard OpenCV interpolation constant, or better to say parameter. Now, if we are able to read the frame, that is, if success is true, we convert OpenCV image to ROS2 image by using self.bridge object and CV to image message frame, and we simply publish the image like this. So what is the catch over here? You cannot simply send standard images that are defined in OpenCV. You need to convert them to ROS2 objects, or better to say to ROS2 messages, and to send them. And on the other side, that is in our subscriber node, we will have to do vice versa. That is, we will have to convert from ROS2 image objects to something that we can show on the screen. That is, we will need to convert ROS2 image objects to standard images such that we can display them. And over here we publish the image. Simple as that. And over here we use the logger to display the messages on the screen. We are saying publishing image number, and we publish the counter number, and we simply update the image counter. Simple as that. Our class starts here, that is on the line 22, and it ends here on the line 80. Next, we need to define the entry point for our code. That is, we need to define the main function. And here it is. In the main function, we initialize the RCLPY by simply typing rclpy.initialize. Then we create the publisher object. Here it is. And over here, we spin our node by simply saying rclpy.spin. And we specify the name, that is the publisher object. Over here, if the user presses Ctrl+C, we need to destroy the node, and we need to shut down our ROS2 RCLPY system. And that's it. And over here you have standard code, if name main, main. Okay, that was our publisher node. Let's save this file and let's close the file. Next, we need to define our subscriber node. To define the subscriber node, we simply need to type this gedit subscriber image.py. So let's run this, and let's again copy and paste the content of the subscriber node. Here it is. Let's go over the subscriber node. The subscriber node will actually receive the ROS2 images, and then it will convert the ROS2 images to image objects and display them on the screen. And again, we need to import OpenCV as import CV2. Then we need to import the standard ROS2 packages and modules. First of all, we need to import RCLPY. Then from sensor messages.messages, we need to import the image. Then from rclpy.node, we need to import node. Then from CVBridge import, we need to import CVBridge. And here, again, we need to define a class that implements the subscriber node. The class starts like this. This class inherits from the node class. And here's the constructor. This function is used to initialize the attributes of the parent class. Then over here, again, we need to create a bridge object or CVBridge objects. To remind you, the CVBridge object is used to convert OpenCV images to ROS2 images that can be sent through the topics. Then we need to specify the name of the topic that's used to communicate the messages. The name of the topic is topic camera image, and here it's very important that this name is exactly the name of the topic that you entered in the publisher node. Then we need to define the buffer size or the queue size, it's 20. And over here we need to say self subscription is equal to self create subscription image, self topic frame, self listener callback function, and self queue size. So what do we do over here? We actually create a subscriber. We need to specify the type of messages that should be received. Then we specify the name of the topic, and over here we need to specify the name of the callback function that's called once the messages are detected through a topic. That is, every time there is an image message, a callback function will be called, and over here we need to specify the buffer size. Now over here I have to warn you about something. you see over here that this line is broken. This should actually be a single line. That is, after self-subscription is equal, you should enter this part over here. There is no line break. That is, this part over here goes here. For some reason, gedit is not able to properly display these type of lines, and this might create confusions since you can see that everything is not properly aligned inside of the def init function. Consequently, keep in mind this. This is very important. Okay, and here's our callback function that displays the received image. What do we do over here? We are specifying the image message, and we are doing this. Display the message on the console. That is, we are saying the image frame is received. Then we use the OpenCV and bridge to convert our message from the standard ROS messages to images that can be displayed on a computer screen, and we obtain our OpenCV image, and after that we call OpenCV image show to show the image on a computer screen, and over here we simply say cv2.wait key such that the user can stop the display. And here is our main function that serves as an entry point. Again, we need to initialize RCLPY, then we need to create the subscriber object over here. Over here we spin, and the callback timer function is called recursively. And finally, if the user presses any key such as Ctrl+C, we destroy and we shut down ROS2. And again, at the end, you have if name main, then main. And that's it. Simple as that. Don't forget to save this file and close it. And let's continue. Next, we need to make sure that the created Python files can be executed. So let's make sure that we are in this folder. And then over here, let's type this to see all the files. And we can see over here that we don't have the executable permissions. So let's set these executable permissions. You simply need to type this chmod.+x to add the executable permission for camera publisher. Then you need to do the same thing for the subscriber image, that is for our subscriber node. And then let's verify that we have all the permissions by simply writing this, and you can see that we can execute both files. Perfect. Next, we need to perform the final edits. First of all, we need to create the entry points. That is, we need to tell to ROS2 from where to start our publisher and subscriber nodes. For that purpose, we need to go to this folder and we need to edit this setup file. Over here, we need to specify the entry points, and to save time, I will simply copy and paste the code that you need to enter. Here it is. Let me copy, let me go here, and let me paste the thing. So what are we saying over here? So we are saying that for console scripts, the publisher node, that's how we call it, will be executed by executing the package ROS2 OpenCV, and inside of this package executing the file camera publisher and going to the main function. That's it. So when someone is actually in a command prompt or in terminal said run publisher node, this will happen. We will run actually the camera publisher inside the ROS2 OpenCV package, and we will start from the function main. The same thing we do for the subscriber node. We will call the subscriber node from the command prompt simply as subscriber node, and when we write subscriber node, we will do the following. We are going to execute the Python file subscriber image and the main function inside of that file, inside of the package ROS2 OpenCV. Simple as that. So save this so we can have the entry points, close and we can continue. Next, we need to verify that all the dependencies are properly installed. For that purpose, go to the base or the workspace folder And over here, type this. I here need to do this. ROS distro I need to change to be Jazzy. This is very important. Oops, I made an error here. And let's see here. Okay, all required ROS dependencies are installed successfully, and this is very, very, very important. Finally, we need to build the Workspace and R packages. To do that, simply you need to type here in the Workspace folder /build. And it's very important to execute this command from the Workspace folder. So let's run this and let's see what will happen. Perfect, it's being completely built. Good. The next step is to test everything. That is, let's run the publisher and subscriber nodes. Okay, so let's close our original terminal and let's start from scratch. So click here and search for terminal and then resize this window over here and then let's run the publisher node. So over here, first of all, you need to source the base ROS environment. Then after that, you need to source the package file. That is, you need to source this file inside our package. This is very important. And now, we need to run the publisher node. To run the publisher node, we need to run this. So what will happen now? We are going to execute publisher node. And if you remember, the publisher node is actually a link to our publisher Python file and to the main function inside of this file. So when we run this, the main function inside of the publisher node will be executed. So let's run this and let's see what will happen. Now here you have to be patient. So nothing is currently happening, right? We are not displaying anything. However, the node is working since we are publishing images, and over here you can see the messages. To see the actual images, you need to run another node. That is, you need to run the subscriber node. For that purpose, open a new terminal over here and let's run the subscriber node. First of all, click over here to source the environment. Then let's source our setup file inside of our package, and over here we will simply run the subscriber node by typing this. So what will happen now? We are going to run inside of the package ROS2 OpenCV this link called subscriber node, and this is actually just a name for the Python file and for its main function that will be executed. So let's run this and let's see what will happen. And here it is. You can see how the messages are nicely being transported and everything works perfectly. And if I put my hand, you can see how everything works more or less in real time. So this is transferred probably with maybe 30 or 40 hertz. This is amazing. Next, let's visualize the communication graph. Simply click here. Then again, click here to source the base environment. Oops, I made an error here. Then click here, or actually type this to source the setup file and run this to see the communication graph. So here's the communication graph. Here it is. Perfect. This is beautiful. Let's bring the messages and the screens. So here's our publisher node. Here's the topic camera image, and here's the subscriber node. Perfect. Works like a charm.